Finding refrigerant leaks, especially small ones that don't impact performance for weeks or even months, is one of the most difficult challenges when repairing an air conditioning system. Yet finding and repairing leaks is critically important for the longevity of a replacement compressor. Even a carefully repaired system can come back prematurely with a catastrophically failed compressor due to an undetected leak. This is because a leak results in the liquid refrigerant level in the evaporator falling over time, causing the oil to drop out and pool in the bottom of the evaporator. The result, of course, is premature compressor failure due to lack of lubrication. In this video, we will demonstrate effective dye leak checking techniques and share some tips to enhance your leak detection success rate. A few things to keep in mind before we actually start leak checking. Always check the dye manufacturer's recommended procedures for using their particular dye and UV light. Some manufacturers add dye at the factory, or somebody else may already have added dye to the system. It is important not to add more dye than is necessary to find a leak. Always check for the presence of dye before adding dye to a system. Excessive dye can degrade the lubrication properties of the oil and actually reduce the intensity of the fluorescent effect, making it more difficult to find the leak. To check if the system may already have dye in it, remove the service caps and shine a UV light in the ports. You should see evidence of fluorescence if dye is present. You can also use a cotton bud to confirm the presence of dye. If dye is already present, you can start leak checking right away. No need to add additional dye. Different UV lights may shine at slightly different wavelengths and also differ in intensity, and dyes from different manufacturers may fluoresce at slightly different wavelengths. Therefore, it's important that your light and dye are a good match for each other. Check that a test sample of dye fluoresces brightly under your light. With this in mind, it's a good idea to use a light and corresponding dye from the same manufacturer. Here, for example, you can see a significant variation in the luminescence of different dyes under the same light, while here you can see varying luminescence of the same dye under different lights. Choose a quality dye that meets the latest Society of Automotive Engineers specification for UV dye. Currently this is SE J2297. This dye will work in both R134A and R1234YF systems and will have no harmful effects on system performance or materials. It is important that the system is fully charged with refrigerant in order to thoroughly distribute the dye. An undercharged system can result in the dye being trapped with oil in the evaporator and not reaching all areas of the system. Add the manufacturer's recommended amount of dye, typically about 1/4 ounce, to the system through the low side service port with a dye injection tool. Run the vehicle with the AC on for at least 20 minutes to thoroughly distribute the dye in the system and to allow it to start showing up at possible leak sites. Wear the yellow tinted glasses that come with your leak detection kit. The glasses accentuate the fluorescence of the dye and also protect your eyes against the damaging effects of UV light. Many modern systems now use compressors with oil retention technology to retain more of the overall oil charge in the compressor. This feature may result in more of the dye being trapped in the compressor. It can take longer for sufficient dye to reach the high side of the system and indicate a leak. Systematically work your way around the system with the UV light looking for evidence of a leak. Even when you find a leak, continue to check the entire system. It is not uncommon to find additional leaks, especially on older vehicles. Use a telescoping mirror to reflect the UV light and check hard to see places. A UV LED light with the flexible gooseneck used in conjunction with an inspection mirror is also useful for checking hard to access areas. Of course, evaporator leaks are the most difficult to find because a direct line of sight to the source of the leak is usually impossible. To improve your evaporator leak detection success, try the following approach, although this technique may not work as well in areas of low humidity. After the dye has been thoroughly distributed in the system, park the vehicle outside in direct sunlight with the doors and windows closed. On a hot summer day, cabin temperature can easily exceed 120 degrees, which could raise static system pressure to 150 psi or more. The increased pressure in the evaporator will help to accelerate the dye leak rate through the leak point. After the vehicle has sat for several hours, place a white polystyrene cup beneath the evaporator drain in a position to catch the condensate. Start the engine and operate the air conditioning system with the system set to fresh air, while collecting all the condensate in the cup. It's important to collect all the condensate right from the beginning. Periodically swirling the condensate in the cup will cause any dye which is present to adhere to the sides of the cup, where it will be easier to see with the UV light. A variation of this technique is to attach a funnel with a piece of clear plastic tubing beneath the vehicle in a position to catch the evaporator condensate. As the condensate runs down the tube, periodically sweep up and down the hose with UV light. Any tiny fluorescent droplets of dye adhering to the inside of the hose will be strong evidence of an evaporator leak. Using these techniques will greatly improve your chances of finding evaporator leaks using dye. When all the leaks have been found and repaired, use a dye neutralizing spray to remove all traces of dye. This will avoid confusion in the event that the vehicle returns in the future with a new suspected leak. Thank you for watching.